All right, here we go. So 1A, we are talking about what are called nets. And it's not like a fish net. It's not a net that you've probably seen before, but they're really cool. So a net is basically a two-dimensional, so flat, right, figure that came from some three-dimensional figure. So it's like this box right here, okay? Would you say this is two-dimensional or three-dimensional? Three-dimensional, okay? So it's taking this three-dimensional figure and making a bunch of cuts and opening it up and laying it out flat, right? This is a net. Isn't that cool?
Wait, so that's what geometry is, taking a three-dimensional object and flattening it?
Nets are taking a three-dimensional object and flattening it. It's one of the things of geometry, right? Okay, so how many different faces, how many different rectangles? Six. Is this the only net you could make for this box?
No. Yeah.
It's not, right? Because I could take this and I could move it here, right? So there's a lot of different nets, which is beautiful because you could all get a different answer and all be correct still. Isn't that lovely? Don't we love it when there's options?
I love that.
Okay, so it says here, this first example, if you fold up the two-dimensional figure at the right, so look at that beautiful, this guy right here. If you fold that up, what three-dimensional object is it going to make?
A box.
A box. Does anyone know a more specific, maybe a more mathematical term?
Square. A cube.
No, a cube. It would make a cube, right? A cube has 6 sides that are all the same, okay? So that's your first note taking. It is a cube. Okay? Okay, now here's the tricky part. You have to try to visualize this. And this is very challenging sometimes for people. Some people get it right away and they're like, yep, that was easy. Other people are like, I don't see it. If you don't see it, it's okay. We're going to figure it out, okay? Here's what I want you to think. Look at this box. Okay? If I were to fold this all up into a rectangular prism, this is not a cube. If I were to fold it all up, okay, what would be across from 6? From this one right here?
1.
It would be 1, right? This is my bottom. Fold it all up. My top is across from it. So 6 is the bottom, 1 is the top, right? What would be across from 4?
2.
Yes, you guys are brilliant. That would be 2. When I fold this all up, 4 is here, right? 2 is over here. Okay, so that's the goal, is figure out what would be across from what on this next one. What would be what would be top and bottom if D is my front? So let's call this the front of my cube, right? So we're going to kind of wrap it around. What's going to be on top? What's going to be on bottom?
What?
E and F, and then A is across from D.
E and F would be your top and bottom, right? So this is going to fold. It depends how you're looking at it. But if D is your front, okay, so let's think of it like this. This isn't the same cube. But let's say this is your front, okay, my number 3, okay? So like this. That means if this is my front, when I fold it up, my top is the one above, my bottom is the one that's down below, right? The horizontal ones, the ones that go across like this, those are all my sides, okay? So when you fold it up, think what's going to be across from the other things. So in this case, what's across from, what are top and bottom? That would be E and F. Okay, so letter B there, you're just going to write in E and F are your top and bottom. Okay, and then if C is my front, if this is the front, what's going to be my left side? What's going to be my right side? Okay, so here's my front. My left side would be here. My right side would be here.
A and C.
So in this case, left and right is going to be A and C. Good.
Always is B and D then in the front and the back?
Yep, so if, oh, sorry, A and C. I was looking at D. I squared D. Sorry, if C is the front, B and D, you're right, will be my left and right. C would be my front, so what's my back? A would be my back, right? So it's kind of taking this two-dimensional thing and folding it up in your brain. Now, if you're doing a homework problem and you're stuck, you do have the option to like cut out a little something and turn it into a box. And that will help you to visualize a little bit. So if you want to do that, by all means, do that. Okay, so what is a net? We said it is a two-dimensional diagram, 2D, that can fold to form a 3D figure. Okay, so take a look at this picture. They give you, anyone think they know what the name of this is? I do not expect you to know this.
Prism?
It is a prism. Good. What kind of prism?
Triangle?
A triangular, Max, for the win. Triangular prism. So this is a triangular prism, okay? That means it has triangle bases, which is tricky because people see it and they're like, that's not a base. The bases are just the two things that are the same, okay? Parallel to each other. So triangular, meaning these two are identical, the front and the back, okay? Can you tell me how you would make a net for that figure? Okay, so I don't have a sample for you on this one, right?
Unfold it.
How would you unfold it? What's that going to look like?
Like this.
Okay, here's a question. You would do it like this.
Yeah.
Okay. How many shapes should there be? 5. There are 5, right? Do you see it? How many rectangles?
4.
0. No,
Oh,
2.
1.
3
3.
rectangles, right? Let me show you. There's this rectangle here. There's this rectangle over here. Where's the last rectangle? The bottom. Okay, so there's 3 rectangles. What are the other 2 shapes?
Triangles.
Triangles. Okay, so now here's where it gets a little bit tricky. We have to draw that as to scale as we can. It doesn't need to be perfect. But whenever there's rectangles, it helps to draw them. Yes, let me see that. That's beautiful. Look what Truett did. You see it? I am going to start on the bottom here. Notice this is a 7x4 rectangle. Okay, so I'm going to draw a 7x4. Now, make sure you label them, right? So we know what's what.
7.
So you start with just a rectangle that's 7x4. Okay. Now, what Truett did and what I would do, you might do it differently, and that's not wrong. Okay, there's multiple ways to get there, but I like to open it up like symmetrical so that it's even on both sides. So I would put, notice this blue rectangle over here is a 7x10. Sorry, a 4x10. I lied. So this is still 4. That's this side right here. And then this side should be 10. Okay. Now my purple, the one I shaded purple, is the same thing, a 4x10 again. So that's going to go on this side. You could put it on the left. I just like it to be symmetrical. And this is a 10. Okay, and then what Truett did was he took those front and back faces, the triangles, and he just laid them down from the from the 7 side. So that's going to be this triangle here, okay, would be my front. And then the triangle in back comes off the back. And those are all 10s. Can you see that yellow? Is that terrible? Not the worst, huh?
So you would want us to label like how long it is and how many sides?
I don't need you to label every single side, but I should have a good feel for where all of the sides should be. Yeah.
Easy.
Okay? You don't have to put centimeters, just the number is fine. Okay. See that rectangular prism there? Now I want you to try. So in that little open space in your notes, see if you can turn that prism into a net. And if yours is different than your neighbor's, it's okay. But I want you to check with your neighbor in just a minute to see if theirs is similar to yours or totally different from yours. you're thinking, how can I take this? It's this, right? It's essentially this. How could I take this net, or this three-dimensional figure, and turn it into a net? So yours could look just like this, or it could be something different. Mine will be something different, because I like symmetry, so. But if yours is not different, that's totally fine.
Wait.
Here's a question to think about. How many rectangles are you drawing?
4.
Ooh. Yes, 4.
Because there's one on top.
But there's more.
There's 6.
There's 6. You should have 6 rectangles when you're done. That looks great.
Wait, those, I thought they were squares.
Yeah, I thought the
Yeah,
sides
they
were
look like
squares, but not.
The sides are 5 by 4, right? The bottom is 5. So it's 5 this way. It's 4, right? The vertical, all of those verticals are 4. So it's almost a square, but it's not quite a square. 5 by 4, 5 by 10, 4 by 10 should be your dimensions. That's great. I would make those maybe a little bit smaller, because just if you think the dimensions. And then don't forget to label the numbers, right? Okay, they're looking pretty good. Here's what I would do. And you have a lot of options. You could go horizontal with it, you could go vertical with it. Because the way this one's set up, I would probably start with a 10 by 5. Like that. Okay, so that's my bottom. And then open up from there. So just above that, I'm gonna do this back face. That's gonna be a 10 by 4. Right, so this is 4 now. Good morning, Mrs. Pfeiffer.
Questions this morning about the handbook?
I think we're good, yeah.
We're bringing pull-ups for the classes.
Yes, just in case, I don't allow bathroom breaks, so they need to go. Yes.
The backpack, like, it says it comes with like a free backpack.
Oh, no, I sure don't. Okay, so then that's your back face, right? I would go with the front face. Here is a 10 by 4. Okay, and then we're gonna have that top face. I'm gonna make that one purple again because it's essentially the same as my other one, 10 by 5. Is that what you did so far? Okay, now the two sides, the 4 by 5. I don't care where you put them. You could put them in a lot of different places, but this right here, I'm gonna go off of the 5 and make it a 5 by 4. And the same thing over here, but maybe you put yours in a different spot. Maybe you put yours here, okay? Or maybe you put one at the top and one at the bottom. That's okay, as long as one's on the left side and one's on the right side, okay? And then just make sure you're labeling those dimensions. Don't you love geometry? Isn't this so fun? Yeah. I love it. It gives me chills. Guys, I just got chills because I'm so excited to be teaching you math. Okay. Last thing. Example 3.
There's a chance that Ryan will be with you next year.
Who's Ryan?
Bonilla.
Yeah,
If he passes this time, he might be with you next year.
He's in 1B right now.
Oh.
He's like,
That's in B, Hall B. So he's,
Oh,
yeah.
Wait, I'll be one in Hall B.
Yeah, this year. Okay, last thing. And we made it. It says each of the following can be assembled into a polyhedron. We'll talk more about polyhedrons as we come, but basically into a 3-dimensional. So here's the 2-dimensionals, right? These are all the nets, which are the 2-dimensional, into these 3-dimensional. I want you to talk to your neighbors and figure out which ones match up with which. Okay, so if you want to draw lines, or if you want to say like number 1 is letter A, it's not, so don't write the A there. But figure out which ones go together, and then we'll check it.
Three, okay, so C is 4.
Oh,
sorry.
sorry.
C goes 4.
So I'm looking at the
B
bottom,
goes
so
A.
A is 3. And
5
then
goes D.
I'm thinking D is 5. Yeah, D is 5. I want to say B is 2. Yeah, I'd say that. And then
Wait,
1 is 1. Yeah.
Have study support.
Bro, academic support? I have academic support and a study center.
Oh, I see it.
Dude, no, study support is fun.
You think like
No, it's so easy. It's a lot of fun, but it's stressful because you have to get like a project on every week.
you
don't have to get it done by
the end of the week.
But no, if you want full credit, if you want. The tests are easy because you can screenshot all the answers after first.
I just pulled up the answers on my phone.
There's easy tests, bro. Easy.
All right, what we get? Number 1 is what letter?
E.
1 is E, correct. Notice 6 squares makes a cube, right? Let's see, who have I not heard from? Luke, what's number 2?
B.
2 is B, good job. Okay. Xavier, what'd you get for number 3?
For 3, I've got A.
3 is A, good job. Max, what'd you get for number 4?
C.
4 is C, great. Notice triangle on bottom, 3 more triangles. And number 5, Isaiah, what'd you get?
D.
5 is D. You guys are brilliant.